students, welcome to the second sessions of this chemistry class 8, that is the metal and non-metals. So before we already discussed about metals, okay, and today we'll discuss about the non-metals. This will be the last sessions. Non-metals are elements which are generally solid and gases. Like the metals, we already know that metals, they are generally solids and which are a good conductor of electricity, right? But generally non-metals here are elements which are generally solids and gaseous. Examples like oxygen, chlorine, hydrogen, etc. and sulfur and all also there, they will exist as solids. Okay, but are almost generally the gases like oxygens. Okay, and oxygen is the supporter of the combustion and also one of the essential gases. All right, yeah. Okay, so properties of non-metals we'll discuss now. Okay, so here number one, non-metals are solid and gas except bromine, which is liquid at room temperature. As you know, in the metals, mercury is liquid at room temperature, right? But like that, here also, here the non-metal, what is that? That is the bromine, which is liquid at room temperature. Yeah. And here comes to, they are bad conductors of the heat and electricity. Why? You may be knowing if you watch the first part. Why? Because there is no electron, that is, there is no free electrons in non-metals. Okay, that's why they do not conduct electricity, but metal do because they contain the free electrons with them. All right. Yeah. Okay. And number third points, they are non-sonorous. We already know the sonorous which give the ringing sounds, right? But non-metals are not. That is the properties. You must keep in mind that the properties, the physical properties difference of metals and non-metals. Okay, generally used to come in the exam. All right, in the number fourth, we will discuss they are non-ductile. Metal are ductile, but non-metal are non-ductiles. So number five, they are non-malleables. As we know, metal are malleable, but just opposite, they are non-malleables. Okay, so they are soft except diamond, which is hardest substance ever. Okay, generally non-metals are soft, okay, very soft, but exceptionally the diamond is the hardest substance ever. Okay, so at this point we have to keep in mind. Number seven, they have the not high, it is low density. Okay, metals have the high density, but non-metals have the low density. And number eight, they are non-lustrous. You know, metal are lustrous, beautiful, handsome, right? But non-metals are not. They are not lustrous. They are dull black. Say, for example, your pencil lead, which is dull black, right? Yeah, but it has only dull bit shining appearance, right? But generally, non-metals are dull and non-lustrous. All right? Yeah. Okay. Now we'll come to the chemical properties of non-metals. Okay. So non-metals react with oxygens to form non-metallic oxide, which are acidic in nature. Okay, so non-metals react with oxygen to form non-metallic oxide, which are acidic in nature. You already know that metals also they form their oxide, but metal oxide are what? The metal oxide are basic in nature, right? But in this case, non-metals also they react with oxygens. They form their non-metallic oxide, but their characters is basic, that is acidic in nature. Okay, that's opposite of the metals. Example like carbon react with oxygen to form carbon dioxide. You know, carbonated drink, you drink the soft drinks and all. Okay, carbonated carbon dioxide is dissolved inside them in the form of the carbonate. Okay, under high pressure. Okay, that's why when we shake it, what happens? That is, it comes out, right? So under high pressure, that is carbon dioxide is get dissolved inside, and their solubility increase, and it form the carbonate, and that carbonated drink, that is the acidic drink only, right? So that is the example. Same thing, sulfur react with oxygen to form a sulfur dioxide, and further on reaction, it will form the acid, sulfuric acid and all also, right? Yeah, and this is the first Okay, and the second here in the chemical properties here in the second point, nonmetals react with hydrogens under the different conditions to form their hydrides. Not in all the conditions, under the different conditions. Say example, the chlorines react with hydrogen to form hydrochloric acid under what conditions? In the presence of sunlight. Okay, in the presence of sunlight, the chlorine react with hydrogens to form hydrochloric acids. Under the normal condition, it will not form, but it should be in the presence of the sunlight. Okay, so hydrogen react with oxygens in the electric spark. Here it will form H2O, not H2S. Okay, so I change here H2O. Got the point? Yeah. So here we'll discuss now here the about third point. Non-metals do not react with water or steams to give the hydrogen gas. But the metals do react with, right? But the non-metals do not react with water or steam to give hydrogen gas. Okay. And here in the number 4, non-metals do not react with dilute acids to give hydrogen gas. But we already know that metals do react, but non-metals do not react with. Okay. So it is because why? Non-metals are an electron acceptor which try to get electrons from others, so that they cannot give electrons to hydrogen ions of an acid. Okay, those who can give the hydrogen ions, which can donate an hydrogen ion, that will be the acid. Okay, but this bases, non-metals, they are electron acceptor. They try to get electrons from others, so that's why they cannot give the electrons to the hydrogen ions of an acid. That's why they do not react with the dilute acids. Okay. Okay, so do metals react with another metals? That is the question. What do you think? Do these metals do react with another metals? Yeah, I think no. Metals does not react with each other to form the compounds, but they do mix with each other homogeneously and to form alloy like bronze, brass, stainless steel, etc. Okay, but metals do not react to form the compound, but they used to combine to form alloy. Okay, bronze, brass, stainless steels, that it is the backbones of the modern industry, right? So they are a mixture only, okay, not only iron along with the carbon, some amounts of the chromiums and all. Okay, so even the gold that when we make the jewelry items and all, so that is also a mixture, we can say, because of the trace amount of like copper or silver are added by the goldsmith to increase the strength, to increase their beauty and all. Okay, so that's right. Okay, so now we'll come here the reactivity series or activity series. Okay, so here the series of the metals, okay, which are arranged in decreasing order of their reactivity is called the reactivity series or activity series. See here the series of the metal which are arranged in decreasing order of their reactivity. Okay, so here you have seen here the potassium. Potassium is what that is the K, and sodium, calcium, magnesium, aluminum, zinc, irons, okay, lead, hydrogen, copper, silver, gold, platinums and all also will be there, right? So here you see here this is the decreasing order only. Okay, so it is given in the decreasing order of their reactivity, and above there that is the most reactive metals. Okay, that is the potassiums. Okay, and the least reactive metals here we take it as gold. Okay, so here see the most reactive metal is potassium. Okay, because it is in the higher reactivity series. Okay, above. So most reactive metal is potassium and less reactive metal is gold. Got the point? Yeah. We have to know this activity series, very important. Okay, now it comes to the displacement reactions. Okay, so the reactions in which the more reactive element displace less reactive elements from their compounds is called displacement reactions. That means the more reactive element can displace, for example, in your friend, okay, the more stronger friends give slave to your friend and he is kicked out, and your another friend, the stronger friend, make friends with you, no? So like that types. Okay, that's example only. So iron displaced copper from copper sulfate solutions. Copper sulfate solution is blue in color to form iron sulfate. It is greenish color, and the copper, that is a brown color. Okay, irons being the more reactive than the copper, so it can displace copper from the copper sulfate solutions and to form the iron sulfates, which is the greenish color, and the copper is leaving behind. So let us see with equations. Okay, so iron Fe plus copper CuSO4 and iron sulfate. See here, copper sulfate is the blue in color, okay, and iron sulfate is the green in color when it's formed, and copper brown color will form. Yeah, okay, now. Yeah, and copper sulfate plus zinc to form zinc sulfate and copper. Okay, so here also chemical equation is that copper sulfate CuSO4 plus zinc sulfate plus copper. What do you think? Copper sulfate is blue in color, but what will be the color of the zinc sulfate? So here the zinc sulfate, its color is colorless. Okay, when the zinc it react with the copper sulfate and it is zinc, it will displace this copper. Okay, and it will form the colorless zinc sulfate. Got the point? Yeah. Okay, now the uses of metals. Okay, as you know, the metals are used to make the machines or machinery, automobiles, aeroplanes, trains, satellites, industrial gadgets, cooking utensils, water boiler, etc. There are many uses in this modern industry. Most of the substance they are made up of the metal, we can say. Yeah, non-metal also having the many contributions, and large contribution is there, no problem, no doubt. Okay, let's see what are they. Uses of non-metals. Number first point, the non-metals oxygen is essential for our life, with all living beings in health during the breathings. Okay, we need oxygen, as you know, not only we, or most of the all the form of the life, that is the living organisms, need oxygen. Got the point? Yeah, except all those viruses and all, right? Yeah. Number two, non-metals like nitrogen and phosphorus are used in fertilizers to enhance the growth of the plants. Okay, nitrogen and phosphorus, they are required by the plants for their proper growth, just as a nutrients for the plants. Okay, yeah, and in the number third, let us go here, and then metals like chlorine and what? The chlorine and the carbons, okay, that is the activated charcoal, and some other compounds are used in the water purification process. You know, chlorine is a poisonous gas. Okay, in the 1000 liter of the water, 1 grams of the chlorine is required to put, okay, to kill all the germs present in the water. Okay, yeah, and this and another say activated carbon or the charcoal is used, okay, as a water purification process, because they can filter all those virus, bacteria and all. Virus can kill by chlorine, and bacteria and some others things that can be what I call filtered by this carbon, or you say the charcoal. Okay, yeah. And number four, the non-metals, iodine is used in the purple color solution, which is applies on wounds as an antiseptic. You say iodine solutions used, or betadines and all, right? So, and ointments, right? So there it contains iodine, and this iodine is good to cure, okay, and it is a good antiseptic, okay, which protects from all those microbes. Okay, yeah. And number five, non-metals, especially the phosphorus, are used in the manufacture of the fireworks. You see there in the matches, okay, on the head of the matches, what you see, the black, or you see the red color, or on its surface also, right? So there it contains the phosphorus, red phosphorus and all. Okay, and they used to have the low ignition temperature. That's why when we strike on the surface, then it gets fire. So They are used in the fireworks. Okay, and not only this one, just about firecrackers and all, they are also we use. Okay, so this is the end of the class. Okay, thank you. I hope you enjoyed the video. Yeah, thank you.